Domain 3 is the biggest domain, 38%, and this deep dive is where we turn your knowledge into exam-ready judgment. Scenario questions in Domain 3 test your ability to select the right control, apply the right framework, and think like a manager rather than a technician. We're going to work through the most common scenario types and traps across all 5 sub-areas. By the end of this video, Domain 3 should feel familiar and manageable. Let's get through it. The mindset for Domain 3 is about balance, technical depth combined with managerial judgment. The exam will present technical scenarios and expect you to select the right control, but it will also test whether you know the manager's role versus the architect's role versus the developer's role. Most appropriate control questions dominate. Your approach? Eliminate the 2 clearly wrong options first, then choose the option that best addresses the root cause of the risk in the scenario. Technical controls answer technical risks. Governance controls answer governance failures. Don't apply a technical control to a governance problem, and don't apply a governance control to a technical vulnerability. Match the control type to the risk type. That's the core discipline Domain 3 tests. For architecture scenarios, here are the traps. Applying traditional network security architecture to AI without modification, AI systems have unique components like model APIs, training pipelines, and model registries that traditional network security architecture doesn't address. Not including AI APIs in the threat model, APIs are the primary external attack surface for most AI systems, and omitting them from threat modeling is a significant gap. Confusing the manager's advisory role with the architect's execution role. The exam uses advise on and design deliberately, and the correct answer changes based on which role is being described. And the correct architectural approach for AI is always zero trust, combined with defense in depth, applied specifically to the AI components, not just inherited from the broader network architecture. Scenario: an AI system will serve external customers through a public-facing API. What is the most critical architecture control? The answer is zero trust. Every request to the AI API must be authenticated and authorized with no implicit trust for external callers. Supporting controls include input validation to prevent prompt injection and adversarial inputs, rate limiting to prevent model extraction attacks through repeated querying, and output filtering to prevent sensitive data leakage. The exam will sometimes offer encryption or firewall as options. These are controls, but they don't address the core architecture risk of an externally exposed AI API. Zero trust is the architecture principle. The others are supporting technical controls that implement it. Lifecycle traps in Domain 3. Running security testing only after model development. Security must be integrated at every phase, starting with planning. Testing after development catches problems when they are most expensive to fix. Decommissioning a model by only deleting it from the production environment. Data must also be sanitized, access must be revoked, and a post-decommission review must confirm no residual exposure. And treating model version control as standard IT change management. AI models need AI-specific controls, signing of model artifacts, provenance verification, and controlled promotion processes. The correct approach is security gates at every lifecycle phase: planning, data preparation, development, deployment, and decommissioning. No phase is exempt from security governance. Scenario: an AI model has passed all functional tests, and the development team says it's ready for production. What's missing? The answer is that functional testing is necessary but not sufficient. TEVV. Testing, evaluation, verification, and validation must be completed before production deployment. Specifically, adversarial testing to check whether the model can be manipulated by malicious inputs. Bias testing to validate that outputs are fair across demographic groups. And robustness testing to confirm the model performs consistently under edge cases and distribution shifts. Functional testing confirms the model does what it's supposed to do in normal conditions. Security validation confirms it behaves safely in abnormal and adversarial conditions. The exam tests whether you know both are required. Data control traps. Treating anonymization as a complete GDPR compliant solution for AI, anonymization reduces privacy risk but doesn't eliminate it, especially when combined with other datasets that enable re-identification. Treating data lineage tracking as optional documentation. Lineage is a security control that enables incident investigation and audit, not just a documentation exercise. And performing bias detection only at model training. Bias must be monitored continuously in production because model drift and data distribution shifts can introduce or amplify bias after deployment. The correct approach is data controls that are continuous, layered, and lifecycle spanning. One-time checks at training are insufficient. The exam will test this specifically. When should bias detection occur? And the answer is throughout the lifecycle, not only at training. Scenario: during a routine audit, a dataset used for training is found to contain data originating from a jurisdiction that prohibits cross-border data transfers. What is the correct response? Step 1. Suspend use of the affected dataset. Don't keep using data you now know is in violation. Step 2. Conduct a data classification review to confirm the extent of the problem and a cross-border transfer assessment to understand the legal exposure. Step 3. Identify the controls needed, data residency controls, legal basis review, and potentially resourcing the data from a compliant provider. The key concept here is that cross-border data transfer restrictions apply to training data, not just operational data. Many organizations assume training data is different. The exam confirms it is not. Privacy and ethics traps. Treating explainability as optional for high-risk AI under the EU AI Act and for automated decisions under GDPR Article 22, explainability is a legal requirement. Thinking federated learning eliminates all privacy risk. It significantly reduces it by keeping raw data at the source, but inference attacks on the model itself can still reveal information about training data. And thinking human in the loop means a human always makes the final decision. HITL means human oversight at a level calibrated to the AI system's risk classification. For low-risk AI, a human review might only be triggered by an exception flag. For high-risk AI, human sign-off is required before action. The exam tests nuance here. HITL is not a blanket rule, it's a risk-calibrated design decision. Scenario: an organization wants to deploy an AI system that will automatically score employee performance and flag underperformers for manager review. What is the most critical first control? The answer is a DPIA, Data Protection Impact Assessment, which is mandatory under GDPR for systematic employee monitoring using AI. This is a high-risk processing activity. After the DPIA, the additional controls that must be in place include a human override mechanism so that an employee can challenge the AI's assessment, an explainability mechanism so that the employee understands the basis of the score, and purpose limitation to ensure the data collected for this AI isn't used for unrelated decisions. Employee AI scoring is one of the highest privacy risk scenarios in the exam. DPIA is always the first step. Let me close with the fast recall for Domain 3. For 3A, architecture, zero trust, defense in depth, threat modeling before building, and cloud shared responsibility model. For 3B, lifecycle, TEVV framework with all 4 components, adversarial testing at deployment, MLOps security in CI/CD, and decommissioning controls including data sanitization and access revocation. For 3C, data controls, full lifecycle data security, classification and provenance tracking, bias detection as a continuous control, and SPOM for supply chain. For 3D, privacy and ethics, XAI techniques including LIMI and SHAP, HIT calibrated to risk, fairness metrics including demographic parity and equalized odds, PETs including differential privacy and federated learning, and GDPR data subject rights. For 3E, controls and monitoring, RBAC and PAM, continuous control monitoring, KPIs and KRIs distinctions, AI tool governance, and board-level risk reporting. That's all of Domain 3 in a structure you can carry into the exam.